Okay, now we're going to do 8-15, C and D. So for C, the question is, how could you rewrite Mariana's balance at the end of any year in terms of the principal, or the $500? In other words, generalize the pattern that you see in this table. Okay, so we're going to try to express what each one of these balances should be by looking at this and finding the patterns that we can capture in an equation or an expression. So the first thing we know is whatever the balance is, it has to be based on that original 500. So we'll take that 500 and put that there. And the next thing is that we know that it has to be multiplied by 1.05. And so we'll go ahead and put 1.05 multiplying that 500. But then we need to somehow capture how many times are we multiplying 1.05? Well, since we've noticed that here, when we had 0 years, there were 0 times that 1.5 was being multiplied. And when we got to the first year, we noticed it was being multiplied only once. And when we got to the second year, we noticed it was being multiplied twice. And when we got to the third year, we noticed it was being multiplied 1, 2, 3 times. And so the way we would mathematically capture a number being multiplied again and again times itself is with an exponent. So I'm going to put the exponent n here. And in this case, n is going to be equal to years. So it's the number of times that it's multiplied. And in this case, it's years. So that will be our n. Okay, so now we have kind of a general rule that we can use, and this will give us the balance each year. Okay, so now, based on this pattern, describe how you would find Mariana's balance after 18 years without first finding her balance of 17 years. Okay, so before, when we were calculating, we just took the previous balance and then we multiplied it times 1.05 to get the new balance, and then we would multiply that by 1.05 to get the next balance. But we're not going to do that in this case. We're going to actually use our new rule. So we know that the 500 is correct because that's our balance. We know the interest rate is correct, and that's that 1.05. And then we need to find the number of years and substitute that for the n. And in this case, it's 18 years. So there we go. That expression should give us the balance for 18 years. Okay, so I'm going to show you how you can get that on a calculator. So if you have a calculator and an iPhone, you just turn it to the side. You can also use the calculator that comes with your book, the CPM book. So both of them have a function that is like this. So I'm going to kind of zero in on that. So I'm going to clear this and then zero in so you can see this better. So you see that it's this function, the x to the y power. So let me show you how to enter in the numbers correctly in order to calculate. So we're going to calculate 1.05 to the 18th power. All right, so the first thing that we'll do is put in the x, which is the 1.05. Okay, so I've entered that in, and now I'm going to go ahead and push this button. Okay, so now that I've pushed that button, I can put in the exponent, which is the y. So my exponent is going to be 18. So I'll put that in now, and then I'll push equals. Okay, so now this number represents 1.05 to the 18th power. And now we just need to multiply it by 500. So I'll say times 500 equals. And so now we know that the balance is going to be 1,203 and 31 cents after 18 years. Okay, so that's how we calculate that.